Hello, I'm Ronald Siepes. I'm working for the Vrije Universiteit Amsterdam, and we are a partner within Interconnect. And this presentation will be about explainability for AI by using visual machine learning representations. Imagine you have an apartment where there are all kinds of sensors. You can think of carbon dioxide meters, temperature meters, humidity meters, how many people are in the room, those kind of sensors. And you have a platform, a database where you store the values that come out of these sensors. Within Interconnect, we are making plugins that transform data that are stored in various databases from various providers and vendors and transform that in a unified format, which is called SAREF. By having this shared language and representation, it makes it easier to make an interoperable communication layer between, for example, a service that predicts the energy consumption based on the values that come from the sensors. SAREF is serialized. So the internal model of SAREF and the serialization is in RDF, so linked data, and that can be represented as a knowledge graph. And this knowledge graph can then uniformly be read via another plugin that again transforms RDF from this uniform format into a table that in this case is being used standard representation for machine learning algorithms. And such a table could look like this, where you have the energy consumption, which is the aggregated value of these some of the sensors, so for example, the energy meters or the heat pump electricity that's being used. And this one is a column containing the outdoor temperatures for a certain point in time. So what we can do with such a table is apply regular machine learning algorithms that can then useful things. Let's say give for a time point in the future based on the predicted weather, what would be the energy consumption for my apartment. A good reason to have that value is, especially if you have variable energy contract, then you can already see how much energy you will use, and therefore also maybe already can make an offer on a flexible market. A subset of these machine learning algorithms, and in this case linear regression and random forests, but there are many of them, they can be graphically represented for a human to understand. So let's start with linear regression. You have various data points, and what you try to do is minimize the error, the distance between all these points. So you try to find the line between all the data points that you have that where the sum of the distances is minimum. That's called linear regression, and that's one of the basic machine learning algorithms. Another one is a bit more complicated, where based on various input parameters, let's say the average temperature per hour, the outdoor temperature, you can have the time of the month, the time itself, and other values. And the model trains a decision tree by itself via a trial and error, and then trying to minimize the error. And then when it stabilizes, or when the algorithm is the error is below a certain rate, the machine learning process will stop. And then this internal structure can be graphically represented in a decision tree like this. So if there are errors, or you have a very unpredicted value, instead of having a black box, you can see what's going on by following the path in the decision tree. So to do this, we implemented Jupyter Notebooks. Jupyter Notebooks are a web-based interactive system where you can program in Python. So here you see that same curve, and we are going to do linear regression. So here's that table, and then I'm not going too much into detail. The code is shared on GitHub, and after some steps, this time this one it stops at 897. It is ready, and you can see here the data points, and this is the line where the algorithm came to. And as you can see, it's quite reasonable. So this is a good representation for anybody to understand. And that helps you, and even the European Union had a white paper on artificial intelligence when it is regarding safety or health or basic human rights. If there is an AI algorithm involved, when there is an outcome, somebody has to be able to explain that outcome. And by having this visual representation and the code, somebody can just go through the steps and verify if this was a reasonable outcome or not. Another example are the random forests. Assume you have a table like this: the year, the month, the day, and the time. This is the energy consumption per hour, and this is the outdoor temperature. And this is on an hourly basis. And we have this data comes from the Constance data set, which is here. The link is also in the slides. It's from various households for 3 years in southern Germany. On an hourly basis, all kinds of devices are being monitored, and the data is shared in these data sets. And we use that to see if we can look at the heat pumps that are in the houses, combine this with another data set, which is the climate data online for that region, and then we try to see if we can predict the energy consumption based on the weather data via this Jupyter Notebook. And first you do some transformation of those tables. Looks like this. And then you do the training step. And then at the end, the system generates a decision tree by itself, and it even renders this plot automatically. And this tree looks the same one as on this slide. And what you also can do is you get the numerical feature importances. So you can also see which one of the parameters were most important. So, and this is not that strange, the average temperature per hour, so the outdoor temperature, has the biggest influence in the decision tree. And this is a plot of the predicted values, and we tested it on the actual values. And you can see that it nicely follows the actual data. Thank you for your attention.